Question number 1. Variables b and t are related by the equation p is equal to p plus q e power 2t, where p and q are constants. It is given that when t is equal to 0, b is equal to 500, and when t is equal to 1, b is equal to 600. Part A, find the value of b when t is equal to 2. We have to find out b when the value of t is 2. Now, before taking out this value, we need to have the values of p and q. To find out these values of p and q, they have given the values of t and b here. We'll get two equations and we will solve those two equations simultaneously. So first of all, we will substitute the value of t as 0 and b as 500. 500 is equal to p plus q e power 2 into 0. Then for the second equation, we will substitute b as 600, p plus q e power 2 into 1. We'll simplify these equations. P plus e power 0 will become 1. So simply we have 500 is equal to p plus q. We can take out the value of one of the variable from this. P is equal to 500 minus q. We'll take this q on other side. We'll solve it. 600 is equal to p plus q e power 2. Now we'll substitute the value of p from here. P is 500 minus q. 600 is equal to 500 minus q plus q e power 2. We'll take 500 on this side. So this will become 100 is equal to, we can rearrange, we can write q e square minus q. And then in the next step, we can take q as common, e square minus 1. So we will have 100 divided by e square minus 1, which is equal to q. And q is equal to 100 divided by e square minus 1 is 15.65. We can substitute this value in this equation so that we can get the value of p. So 500 minus 15.65 is equal to 484.34. Now we can substitute these values in the equation. B is equal to P, which is 484.34 plus 15.65 e power 2t. Now we have to take out the value of b when t is equal to 2. So we will substitute the value of t as 2. When you will solve it using calculator, you will get 1338.8, which will round off to 1339. Part B, find the smallest value of t that gives a value of b greater than 2 million. So we have equation b is equal to 484.34 plus 15.65 e power 2t. In place of b, we will be writing 2 million is equal to 484.34 plus 15.65 e power 2t. Then we will take this on this side and we will subtract it. Minus 484.34 is equal to 15.05 e power 2t. E power 2t is equal to, we'll subtract these values, we'll be getting 127764.5789, and then we will apply ln on both sides. Q2 ln E is equal to 11.7579. ln E is 1, so T is equal to 11.7579 divided by 2. T is equal to 5.8789, which is 5.88. So this is the value of T, which will give the value of B greater than 2 million. Question number 2. Find the coefficient of x squared in the expansion of x minus 3 upon x into x plus 2 upon x with power 5. So first of all, we will expand this x plus 2 upon x to power 5. We have the formula NCR a power n minus r b power r. In this case, n is 5, a is x, and b is 2 upon x. Let's substitute the values. NCR 530, x power 5 minus 0, 2 upon x with power 0, which is equal to 530 is 1. X power 5 minus 0 is x power 5. 2 upon x with power 0 is 1. So we have x power 5. Then we'll do 5C1, x power 5 minus 1, 2 upon x with power 1, which is equal to 5C1 is 5. X power 5 minus 1 is x power 4. 2 upon x with power 1 is 2 upon x. So when we will solve it, 5 multiplied by 2 is 10. X power 4 divided by x is 10x cubed. Then 5C2, x power 5 minus 2, 2 upon x with power 2 is equal to 5C2 is 10. X power 5 minus 2 is x power 3. 2 upon x with power 2 is 4 upon x squared. Equal to 40x. As we have to multiply it by x minus 3 upon x, when we will multiply x by x, we will be getting x squared. When we will be multiplying 10x cubed by 3 upon x, we will be getting the term in x squared. As we require the term in x squared, we don't need to expand it further. So x plus 2 upon x with power 5 is equal to x power 5 plus 10x cubed plus 40x. Now we will write x minus 3 upon x multiplied by x plus 2 upon x with power 5. We will write here the expanded form of this bracket, which is x power 5 plus 10x cubed plus 40x. As we require the coefficient of x squared, so we have to multiply x by 40x. So we will get 40x squared and minus 3 upon x by plus 10x cubed. So we will get minus 30x squared. So it is 10x squared. Therefore, the coefficient of x squared is 10. Question number 3. The graph shows part of the curve y is equal to sec squared up x upon 2 plus e power x, and the lines x is equal to pi upon 4 and x is equal to pi upon 2. Find the area of the shaded region. Give your answer correct to 2 decimal places. So as we have to find out the area of shaded region, which is equal to area under this curve. So how we take out area under the curve? By integrating this curve and the limits to be pi upon 2 till pi upon 4. Then we will integrate this. We will get tan x upon 2. So we divide this by 1 upon 2 plus, when we will integrate e power x, it will be e power x. And the limits are from pi upon 2 till pi upon 4. We can write it as 2 tan x upon 2 plus e power x. Now we will substitute the value of x as pi upon 2 and another time pi upon 4. So it is 2 tan. When we will substitute here x as pi upon 2, it will become pi upon 4 plus e power pi upon 2. Minus, we will substitute the value of x as pi upon 4. So this will become 2 tan pi upon 8 plus e power pi upon 4. When we will solve it using calculator, we will get the answer as 3.79. Question number 4, part A. In an arithmetic progression, the first term is 176 and the 10th term is 149. Find the common difference of the progression. We have first term as 176. So it means A is 176. 10th term is 149. Formula for 10 term is a plus 9d, which is equal to 149. Now, as a is already given, so we can substitute the value of a here as 176 plus 9d is equal to 149. So 9d is equal to 149 minus 176, which is minus 27. And d is equal to minus 27 divided by 9, which is minus 3. Part 2. Find the least number of terms for their sum to be negative. So we have to use here sum formula, which is n upon 2 a plus n minus 1 into d. And the sum must be negative. It means that the sum is to be less than 0. Now we'll substitute the values. We have to find out number of terms. It means that we have to take out n upon 2. A is 352 plus n minus 1. D we have taken out as minus 3 is less than 0. N upon 2, 352 minus 3n plus 3 is less than 0. We will multiply this 2 by 0, so this will become 0. And we will multiply n by the bracket, so this will be 352n minus 3n squared plus 3n is less than 0. Now we have minus 3n squared plus 355n, which is less than 0. Now we will make this positive, so it will be 3n squared minus 355n is greater than 0. Whenever we change the signs in an inequality, then we have to change the sign of inequality as well. Now we will take n as common. 3n minus 355 is, as we have quadratic inequality, so we will take out critical values. N is equal to 0 and 3n minus 355 is equal to 0. So 3n is equal to 355 and n is equal to 355 divided by 3, which is equal to 118.3. Now, if we'll draw it here, we have n is equal to 0 and n is equal to 118.3. The curve would be like this. We have to consider the greater part. So it means that we have to consider this part of the curve and we have to consider this part of the curve. So n is either less than 0 or n is greater than 118.3. As we have to find the least number of terms for their sum to be negative, we have to consider the value, the integer value, which is greater than 118.3, which is 119. So the least number of terms for their sum to be negative is 119. Part B, in a geometric progression, the first term is 3 and the second term is 2.4. Find the sum of the first 8 terms of the progression. We have first term 3 and second term 2.4. So A is equal to 3 and R is 2.4 divided by 3, which is 0.8. As we have to find out sum of the first 8 terms of the progression, so we will write S8 is equal to A, which is 3, 1 minus R, 0.8 to the power n, which is 8 here, divided by 1 minus 0.8. So when we will enter it in the calculator, we will get the answer as 12.5. Second part, find the sum to infinity of the progression. For sum to infinity, we have the formula A upon 1 minus R. A is 3 here, 1 minus R, 1 minus 0.8. So it will be equal to 50. Starting with the 10th term, find the sum of 50 terms of the progression. As we have to find out the sum of 50 terms that is starting from 10th term. So we will consider 10th term as first term. 10th term is equal to A r power 9, which is 3 into 0.8 power 9. And this 10th term is to be considered as first term. S50 is equal to 3 into 0.8 with power 9, 1 minus 0.8 with power 50 upon 1 minus 0.8, which is equal to 2.01. Question number 5, part A. 4-digit numbers are to be formed using 4 of the digits 2, 3, 7, 8, and 9. Each digit may be used once only in any 4-digit number. Find how many 4-digit numbers can be formed when there are no restrictions. As we have to form 4-digit number out of 5 numbers, so we can simply use here 5p4, which is equal to 120. Second part, find how many 4-digit numbers can be formed when the number is even. We have to find out how many 4-digit numbers can be formed when the number is even. It means that the last digit will be either 2 or 8, because if the last digit is even, then the whole number is even. The last digit here can be 2 or it can be 8. So we just have 2 options for the last digit, and then out of 5 digits, 1 digit is fixed over here. So remaining are 4. So here is a possibility of 3 digits. Here is the possibility for 2 digits, and here 2 digits. Same is the case here, 4, 3, 2. So it means that we will be multiplying 4 into 3 into 2, and we have 2 cases, 1 and 2. So we will be multiplying it by 2. 2 multiplied by 4 multiplied by 3 multiplied by 2 is 48. Part 3, find how many 4-digit numbers can be formed when the number is greater than 7,000 and odd. If a number is greater than 7,000, then the first place there can be 7, there can be 8 or 9. And the last digits can be 3, 7, and 9. Let's see the possibilities. 7 is there at the first place and 3 is there at the last place. 7 at first place and 9 at the last place. First place 8, then 3, the last digit. 8 is the first digit. 7 is the last digit, or 8 is the first digit and 9 is the last digit. We cannot take 7 with 7 because 7 is there at first place, then 7 cannot be at the end. Each digit can be used once only. Another option, we have the number is starting with 9 and ends at 3. Then starting with 9 and the last digit is 7. We cannot have 9 here if the digit at first place is 9. So we have total 1, 2, 3, 4, 5, 6, 7 possibilities. And these numbers are fixed. Here we can have, if 2 digits are over here, then at this place there is a possibility of 3 digits. And here the possibility of 2 digits. And in all these cases, it would be same. So simply we'll multiply 7 by 3 and then by 2. So 7 3s are 21 and 21 2s are 42. So there are 42 4-digit numbers which can be formed when the number is greater than 7,000 and it is odd as well. Part B, find the number of ways 12 people can be put into 3 groups containing 3, 4, and 5 people. So we have to make 3 groups. One of 3 people, second of 4 people, and third of 5 people. In the first group, out of 12, there are 3, so 12C3. In second group, from the remaining 9 people, we have to put 4 people. So 9C4. The remaining are 5, and those 5 people are to be kept on the third group in which there are 5 people. Now we'll multiply these 3, 12C3, 9C4, and 5C5. So the answer is 27720. So there are 27720 ways to put 12 people into 3 groups containing 3, 4, and 5 people.